Deep within the archives of aerospace history lies a blueprint for a machine so audacious, it borders on science fiction, the Super Nexus, a nuclear-powered rocket conceived in the ambitious era of the 1960s. This was a time when humanity's dreams of space seemed limitless, and engineers dared to imagine technologies that could reshape our destiny among the stars. Designed to lift the weight of a naval destroyer into orbit, the Super Nexus was more than just a launch vehicle. It was a bold vision for humanity's rapid expansion into the cosmos. Its sheer scale and power would have made it the most capable rocket ever built, opening the door to missions that today still seem out of reach. The Super Nexus wasn't a failure. It was a dream too immense for its time. Political realities, budget constraints, and public fears about nuclear technology forced it back into the shadows, leaving only blueprints and what-ifs behind. Today, as we enter a new space age filled with private companies and renewed lunar ambitions, this forgotten concept is more relevant than ever. The challenges it sought to overcome, massive payloads, deep space travel, and sustainable infrastructure, are the very same ones we face now. The Super Nexus marked a fork in the road, a path not taken, with a scale and propulsion system that could have fundamentally changed our relationship with space. Its nuclear engines promised faster journeys and heavier cargo, rewriting the rules of what was possible. It was about building permanent highways to the Moon, Mars, and beyond, not just planting flags, but establishing a true human presence in the solar system. Imagine colonies supplied in a single launch, or missions to Mars measured in weeks, not months. Partially reusable, the Super Nexus could deliver payloads that make even today's starships seem modest by comparison. Its capabilities would have dwarfed anything before or since, setting a new standard for what rockets could achieve. As we watch modern rockets reach for the heavens, the ghost of Super Nexus lingers, challenging us to ask, are we dreaming big enough, or have we let caution eclipse our cosmic ambitions? The same challenges, cost, travel time, and infrastructure, still define space exploration today. Despite all our advances, the fundamental obstacles remain, echoing the questions the Super Nexus once tried to answer. Now, the bold ideas of reusability and nuclear propulsion are back at the forefront, proving that truly visionary concepts never truly die. They simply wait for their moment to return. The Super Nexus stands as a cosmic benchmark, urging us to revisit the scale of our ambitions and reminding us that the future of space is limited only by the size of our dreams. The 1960s, fueled by Cold War rivalry, sparked a race for the ultimate high ground: space. The world watched as the United States and the Soviet Union competed not just for technological supremacy, but for the very future of humanity beyond Earth. Every rocket launch, every mission control countdown was a move in a high-stakes chess game that would define a generation. In this crucible of innovation and tension, the Super Nexus was born, conceived by Convair and General Dynamics and led by the visionary engineer Kraft. Erika, a German émigré and rocket pioneer, brought together a team of dreamers and doers determined to push the boundaries of what was possible. Erika saw that conquering space required more than tiny capsules for astronauts. It needed a true cargo freighter for the solar system, a vessel capable of carrying not just people, but the tools and materials to build a new world beyond Earth. The radical idea was a single stage-to-orbit vehicle powered by nuclear engines, a leap far beyond the chemical rockets of the era. This was not just an incremental improvement, but a bold reimagining of what a launch vehicle could be. While Project Orion and Rover explored the raw potential of nuclear propulsion, Super Nexus aimed to make it reusable, reliable, and truly massive. It was designed to be the workhorse of a new space age, not just a one-off experiment. Erika envisioned bustling lunar bases, permanent outposts on the Moon, and crewed Mars expeditions, ambitious dreams that demanded a revolution in launch capability. Super Nexus was the key to making these visions a reality, enabling missions that were previously unimaginable. In the context of the space race, no idea was too bold if it promised an edge. The pressure to innovate was relentless, and the stakes could not have been higher. Super Nexus was the ultimate trump card, a symbol of American ambition, technological prowess, and industrial might. It represented the hope that the United States could lead humanity into a new era of exploration. For Erika, rockets like Super Nexus were more than machines. They were instruments of destiny, unlocking a future where humanity was no longer confined to Earth, but free to explore, settle, and thrive among the stars. To truly grasp the ambition behind Super Nexus, you have to look at the staggering numbers: 400 feet tall, 150 feet in diameter, and engineered to lift an incredible 500 tons to low Earth orbit. These aren't just statistics, they represent a leap in what humanity has ever attempted in spaceflight. Imagine a rocket so large it would dwarf even the most iconic launch vehicles in history. That's nearly 4 times the Saturn V's legendary capacity, and more than Starship, SLS, and Saturn V combined. No other rocket, past or present, comes close to matching this scale or capability. This wasn't just incremental progress, it was a quantum leap, a bold reimagining of what rockets could achieve. Super Nexus would have redefined the limits of engineering and human ambition. Its power source? A cluster of advanced nuclear thermal rocket engines, each one heating liquid hydrogen to extreme temperatures, unlocking levels of efficiency and thrust that chemical rockets simply can't match. This technology was decades ahead of its time. Thanks to this unmatched efficiency, Super Nexus could achieve single stage to orbit, a feat that remains out of reach for even today's most advanced rockets. It was a vision of true reusability and operational simplicity. The sheer scale of Super Nexus would have transformed every aspect of space operations, from launching off repurposed offshore platforms to assembling spacecraft in vast cleanrooms and transporting enormous payloads in cavernous bays. It could carry entire space station modules, interplanetary ships, or even the building blocks for a future lunar city, enabling missions that were previously unimaginable. Super Nexus was designed for colonization, not just exploration. It was built to deliver the infrastructure needed for permanent human presence on the Moon, Mars, and beyond. Its revolutionary design promised to make spaceflight routine, not rare, envisioning a future where launches could happen as frequently as commercial flights. The sheer ambition and vision of Super Nexus remain unmatched in the history of rocketry, a testament to what humanity can dream, and perhaps, one day, achieve. Despite its promise, Super Nexus never left the drawing board. The technical challenges, scaling up nuclear engines, were immense and risky. Financially, the project would have dwarfed even Apollo's budget, making funding nearly impossible. NASA and the Department of Defense prioritized the proven Saturn V to meet the urgent goal: beating the Soviets to the moon. Politically, support for space was tied to that singular achievement. Once reached, enthusiasm and funding waned. Launching nuclear rockets from Earth also raised serious safety and environmental concerns. Ultimately, NASA chose a conservative path: expendable Saturn V, then the partially reusable shuttle. Super Nexus became a what if, a symbol of dreams too bold for their time. If Super Nexus had flown, the 21st century would look radically different. Its massive, reusable capacity could have slashed launch costs, opening space to industry and science decades earlier. Orbital manufacturing, space-based solar power, and asteroid mining might be established realities. Permanent lunar bases could have been built in the 1980s, with crewed Mars missions in the 1990s. The space economy would have boomed, shifting the Cold War's focus from prestige to industrialization and colonization. The US would have held an unassailable strategic advantage in space. Technological breakthroughs in materials, robotics, and nuclear engineering would have arrived sooner. Mastering nuclear propulsion would have made rapid solar system travel routine. The technologies for reusability and autonomy would have predated Shuttle and Starship by decades. We'd be living in a future built on 1970s nuclear rocketry, exploring the outer planets with confidence. The path not taken by Super Nexus led to a different lineage of heavy-lift rockets. The Saturn V, a masterpiece, sent humans to the moon but was fully expendable and unsustainable for routine use. After Apollo, the US lacked a super heavy-lift rocket for decades. The Space Shuttle introduced partial reusability, but high refurbishment costs limited its impact. The shuttle built the ISS and deployed Hubble, but never left low Earth orbit. Today, a new era of giant rockets is emerging, driven by private ambition and renewed national interest. NASA's SLS is powerful, but still expendable, keeping costs high. SpaceX's Starship, echoing Super Nexus, aims for full reusability and massive payloads. Starship's rapid development and iterative philosophy bring the Super Nexus vision closer than ever. The dream of routine, affordable access to space is finally within reach. For decades, nuclear propulsion was sidelined by technical and political hurdles. Chemical rockets were reliable, but as we set our sights on Mars, their limitations became clear. Nuclear thermal propulsion, as envisioned for Super Nexus, offers far greater efficiency, cutting travel times and increasing payloads. NASA's Draco program is now reviving this technology, aiming to test a nuclear rocket in space by the late 2020s. Success would pave the way for large-scale human missions in the 2030s and beyond. Nuclear electric propulsion is also gaining interest for deep space probes and cargo. Companies are developing compact reactors, bringing the dream of nuclear-powered spaceflight closer to reality. The atomic rocket era, once shelved, is reawakening. The Super Nexus story is inseparable from Croft Erica, its chief architect and advocate for humanity's cosmic destiny. Erica's extraterrestrial imperative argued that expanding into space was essential for our survival and growth. He saw rockets like Super Nexus as the first steps toward a civilization that harnesses the solar system's resources. Today, his forward-thinking ideas resonate more than ever. Modern space leaders, like those at SpaceX, echo Erica's philosophy, pushing boundaries and embracing rapid iteration. Digital recreations and CGI bring these bold concepts to life, inspiring a new generation. The conversation started by visionaries like Erica continues, fueling the public imagination. The saga of Super Nexus is about the power of imagination, a refusal to accept the status quo. Its designers weren't just building hardware, they were composing an unfinished symphony of exploration. Today's pursuit of reusability and nuclear propulsion revives that dream. Now, within reach, thanks to decades of progress. The Super Nexus reminds us that progress isn't linear. Sometimes, we circle back to brilliant ideas left behind. Studying these audacious concepts fuels innovation and inspires the next generation to ask, what if? The final frontier demands our boldest dreams and greatest courage. The ghost of Super Nexus isn't a warning, it's a beacon, calling us to finish the symphony and build the highways to the stars.